In this video, we are going to look at what we call stars and bars problems, which I prefer to call trees and yards problems. Before watching this video, I have some activities to help you understand the concepts underlying these problems. It might be helpful to look at them. It's in the file called Trees and Yards. These hopefully will make the video easier to understand. I should make you aware that those problems are not on the quiz, but they will help you build the understanding that will maybe help you get a little more out of this video. All right, so we're going to firstly briefly discuss what the trees and yard problem is. We are going to explain how we use stars and bars as shorthand for the exact same types of problems. We're going to work a trees and yards problem, stars and bars problem. And then we'll think about what kinds of problems can be translated into trees and yards. It's important to remember that these are really metaphors for a larger set of problems, and being able to fit those in properly it can be really helpful. All right, so suppose you have some identical trees, say R of them, and you have N backyards, and you want to put those trees into the yards. So the way we have these backyards organized are they're just lined up in a row, and we separate them by fences, only as many fences as we need to keep the backyards separate. So the question we ask is, how many ways can we place these trees among the yards, including the possibility that some yards have no trees? So first of all, we want to separate the yards using fences. If we have n yards, we can separate them with n-1 fences. We can then represent each placement, as you saw in the activities, by a sequence of trees and fences. So if we were to have 3 yards and 5 trees, 3 yards means 2 fences, here's what one possible sequence might look like. Notice that we have 2 F's for the fences, and we have 1, 2, 3, 4, 5 different trees that we put in there. And what that means is that we have 1 tree in the first yard, then we have a fence. We have 3 trees in the second yard, then we have another fence, and then we have 1 tree in the third yard. And if we were to think of T as representing the digit 0, F as representing the digit 1, then that TF, TT, TFT is just a bit string, right? And it's in fact a bit string of length, well, the number of trees, that's some of our bits, and the rest of our bits are the fences. So R is the number of trees, n-1 the number of fences, R plus n-1 is going to be the length of our bit string. And since we are representing F's by the digit 1, since we have n-1 fences, that means the weight of our bit strings is n-1. Now, there's no reason we can't let the trees represent the digit 1 and the fences represent the digit 0. That's fine. We will still have the same length, R plus n-1, but now since F represents, or T represents the digit 1, that means our weight is now going to be the number of trees, which is R. And if we want to count all the possible ways we can do this, our solution is length choose weight, as it has been this entire time, looking at bit strings. And that means we either get R plus n-1 choose n-1 if our fences are our digit 1, or we get R plus n-1 choose R if our trees are our digit 1. So if you go around talking about trees and yards to people, they might think you're a bit strange because that is not the standard way we think about those problems, but they do correspond in the traditional way. So we use stars instead of trees, and we use bars instead of fences when we set up our bit strings. So for instance, if we have, in this case, let me see, we have 4 different yards because we have 3 fences, and we have 1, 2, 3, 4, 5, 6 different trees. Each of our trees becomes a star, each of one of our fences becomes a bar, so we get 1 star for our 1 tree, then a fence, that's our bar. Then we have 3 more trees, that's 3 more stars. Then we get another fence, that's our bar. We get 2 more trees, that is also stars. And then a fence at the end, that's a bar. So stars and bars is the standard way that people tend to think about those. But the counting is exactly the same. We could either think of the stars as representing 0 and the bars as representing 1 in our bit string. Or we can think of stars as representing 1 and bars as representing 0. The counting is exactly the same. So let's go ahead and work an example. Let's suppose you have 5 candidates running for office and we have 500 voters. How many ways can we count the votes? Can the votes for the candidates be distributed among them? And when we're counting this, I'm talking about the number of votes. So, for instance, if in one election 5 candidates votes for candidate A, and in the next election a different 5 people vote for candidate A, but still 5 votes, I'm going to count that as the same outcome. So it's just how many different vote totals for each candidate can you have in this election. So it may not seem at the beginning like this is a trees and yards problem, but if you think of the candidates as the yards and the voters as the trees, what we're doing is we're attaching each voter to a candidate, right? And so that's the same as attaching each tree to a yard. So the votes belong to their candidate just like trees belong to the yard. So we have 5 candidates. How many fences? That means we have 4 fences, or 4 bars if you're a stars bars person. We have 500 voters. Those are the trees in our model. Or those are 500 stars if you're a stars and bars person. And so if we want to count all the different ways that we can do this, the length of our bit string is the total number of stars and bars. Total numbers of trees and fences, that's 504. And the weight of the bit string is going to be 4 if you're a fence bar person, 500 if you are a tree star person. Which means that your answer in terms of the counting is 504 choose 4, or 504 choose 500. Exact same number, just a different way of representing it. So looking back at that problem, it might be helpful to think about, how do I recognize a trees and yards problem, stars and bars problem, if I encounter it? Well, think about what the yards represent. What the yards really represent are categories. These are the categories that the trees go into, right? So you have each yard represents a category that the trees goes into, just like each candidate in the election represented a category that our voters got associated with. The trees then, these are items that are distributed between those categories. They belong to those categories after the process ends. What's really important here is the trees must be identical. We can't tell the difference between one tree and another, just because, like in the voter problem, I didn't want to say, I didn't care who voted for them, I just voted about the vote total. I don't care about anything about the trees except how many there are in each yard. But once we distribute the trees into the yards, once we distribute our items into the categories, they are now sort of distinguishable, right? The items within a category, you can't distinguish between those. But you can distinguish between items in different categories, but only that they are in different categories. All right, so with this in mind, I would encourage you to try to finish up the trees and yards problem if you weren't able to finish those to help you understand the concepts here. But you can go ahead and also work on the stars and bars problems. Those are the ones that are going to be on the quiz, and those are on the PDF files included with this video.